Okay, the line through here, you can use the specific formula mentioned in the book, but in practice it's good to just get a feel for it by doing it from first principles. So here's the first point, 0, -1, and then it's 3 and 5. So let's put that there as a sketch. And here's our straight line. So the nice thing is we've already got the intercept here. So if we just got the gradient, we could do y equals mx plus c, couldn't we? This would be one way to do it. So we know c is -1 here because it's given. M would be the triangle under the curve. There, so it would be the difference in y would be 5 to -1 is 6. Difference in x is 3 to 0. 6 over 3 is 2. So m equals 2, c equals -1, and that would give y equals 2x minus 1. This would be the equation of the line. Supposing this wasn't so convenient here, how would you do it? Well, you'd have your point here. You could label it xy, and you could do your triangle from here to here. So you could say y minus the y value, -1, divided by x minus the x value, x minus 0. So that slope there, the opposite over the adjacent, the slope ratio, gradient in other words, is equal to, and then we know the gradient from working out this triangle here between 2 points, is 2. So that tells us then y plus 1 is equal to, and then we can move the x up to be 2x, and then that tells us, move the 1 over, 2x minus 1, which is what we wanted. This is generally, if this point hadn't been so conveniently located, where we use this approach, this would be the general approach. Just write the general point on the line. We know that the height over the distance across, that ratio is the gradient, which is 2. We worked out it was a gradient because we knew these 2 points were on the line. The difference between the y's divided by the difference between the x's is 2. So that would be 2 then. And then we just did the algebra and got the equation of the straight line. So it has gradient to intercept -1.